Okay, question 3. So this is great. This is an excellent question in relation to experimental design. All right, so an investigation was carried out into the effect of a competitive inhibitor on the activity of phosphatase at different substrate concentrations. Okay, so again, that has already told us what the aim is. So an investigation was carried out into the effect of a competitive inhibitor on activity of phosphatase at different substrate concentrations. Phosphatase is an enzyme which catalyses the reaction shown. So again, don't worry, remember, I know some of you will probably see these kind of words and you go, my teacher's never taught me about this. This information is not the important bit of the information. For you, it's important that you understand how an enzyme reaction occurs and the reactants and the products. What does this arrow represent? You know, the conversion between the substrate to the product. Okay, the fact that you need a substrate for the enzyme to act on, and then you have your products. These are the important bits. Okay, so don't worry too much about the big fancy words. So it says 6 test tubes, each containing a different concentration of substrate, were set up. The inhibitor and then the enzyme were added to each tube. So figure 1 shows the contents of each tube. Okay, so here we have, so we've got our enzyme, our inhibitor and our substrate, and then we've got our volume of each. Okay, it says after 30 minutes, 1 cubic centimetre of alkali was added to each tube. Okay, phenylphthalein turns pink in the presence of alkali. The more phenylphthalein produced, the more intense the pink colour and the higher the absorbance reading measured by the colorimeter. Okay, so it says table 1 shows the results of the investigation. So again, getting comfortable with the data before we attempt the questions. I can see here, so concentration of substrate in moles and absorbance units. So the colorimeter relates to this. Okay, so I can see that as the concentration of substrate is increasing, okay, the absorption units are also increasing. All right. So again, thinking about what a competitive inhibitor is. So a competitive inhibitor binds on to the active site. Okay, so prevents the substrate from binding. All right. So as the substrate concentration increases, the absorbance units also increases. So we'll come back to this later on. So question 1, so question A, suggest while alkali was not added to each tube at the start of the investigation. Okay, so the alkali is telling us if the reaction is occurring or not. Are we getting these products? Okay, so if we added it straight away, it would almost give us like false positives. We've not allowed the reaction to take its course or run its course yet. Okay, so the correct answer would be to allow time for reaction to take place. Or you could say something to allow the substrate to be broken down or something. Okay, and then B, state 2 variables other than those shown above which should be kept constant to make this investigation valid. Okay, so we need 2. So remember when we're doing our variables, the kind of clue for me is that the kind of main words we're going to be using is we're either going to be using volume, concentration, temperature, or there could be something to do with a surface area or equipment. Okay, but these are really your main areas you're going to be looking at. Okay, so we know straight away we can't mention volume. So again, I'm going back to the kind of experimental image, because volume's already stated. Okay, so state 2 variables other than those shown above. So we can't use volume, but we can use concentration. Okay, so we don't know what they don't tell us what the concentration is. So to keep it right, we would have a concentration of inhibitor. We don't know alkali, enzyme, or the phosphate. Okay, so concentration of any of these solutions. Okay, and then we could have temperature, but remember, you have to have temperature of something. So I would have temperature of solutions and test tubes. Okay, and a final one you could have had was the type of alkali. It doesn't tell you essentially what's being used. Okay. All right. Okay. So your next one is your graph. Okay. And as you would have learned from one of the questions, to really take your time with your graphs. Okay, so it says, construct a line graph to show the data in table 1. Okay, so I know what my data is here. I'm going to have my data in front of me. Okay, this is nice and big. And remember, the most important thing here is if you do make a mistake, go and use your additional paper. And then if you make a mistake in that, put your hand up if you're in an exam situation and ask for more graph paper. An invigilator or your teacher will give you more graph paper. Most important thing is, we're going to create a line graph. We're not going to do a bar graph or a pie chart. We're going to do our line graph. Okay, so first thing we need to get right is the labels, and obviously what is going on what axis. Okay, so we know that what is basically being changed, okay, is going to go down on your x-axis. Okay, so that variable that's going to get changed, that independent variable is on your x-axis. So that is therefore, I'm going to kind of squeeze it in here, concentration of substrate. And always remember units, and that's in moles. Okay, and then just going to turn this to the side for a wee bit. Okay, my y-axis is therefore absorbance. I'm going to have that in units. So remember, when you're doing your graphs, you're basically writing down exactly what's already on the table. The headings for the tables must be the exact same headings on your graph as well. Okay, and they've made the scale kind of nice and easy for us. Okay, so I'm going to have here 0.10, 0.20, 30, 40, 50, 60, 70 and 80. Okay, so my concentration of substrate from 0.05 all the way up to 80. Okay, and then absorbance units, again they've kept it nice and easy. Okay, 0, and again you could have a double 0 there. Okay, that would be 0.10, 0.2, 3, 4, 5, 6, 7, 8 and 9, because we know our scale is going from 0.2 to 0.9. Okay, but we're going to have one continuous scale and not just the specific data. All right, so we've worked out what's independent variable, what's the dependent variable. We've worked out, we've labelled, okay. And the next thing is to plot our data. Okay, so our first one is 0.05. Okay, so when I'm going along here, Okay, I know, so that's 2, 4, 6, 8. Okay, so I know my 0.05 is bang in the middle here. Okay, and then the absorbance units is 20. So I have to make sure I'm going all the way up and plot it nice and neat to make it obvious. Okay, remember, no big stars and circles and stuff like that, because you might go over another line and the marker might not know what line or what does your point represent, what number. Okay, my next one is at 0.10 is 30. Okay, so here's my 0.10. I'm going all the way up to 30. That's a nice and easy one. So I'm one of the major grid lines, remember them bolded lines. My next one is 0.20, which represents 0.48. Okay, so make sure I'm tracking all the way up nice and carefully. So each box representing 2, so 0.4, so 0.42, 0.44, 0.46, 0.48. Okay, and then 40 is 0.64, so again going all the way up, just stopping at times just to make sure I'm okay. Okay, so 0.62, 0.64. Okay, and then 60, 0.78, so again tracking all the way up, just stopping at times to make sure I'm still okay. 0.78, 2, 4, 6, 0.78. Might be a wee bit hard for you to see what I'm doing as my hands over the line, sorry. And then 0.80, so 0.90 line, stick to my major grid line all the way up. 0.9, nice and easy, 0.9. So nice clear points. Okay. So the next thing to do is get my ruler. Okay. Make sure the line is right through the middle, not to the side, not underneath. And if you're unsure before you draw the line, match them up. Make sure that looks like it's going to go right through the middle. Okay, line graph done. So I want to make sure, is my points neat and small? Yes. Have I used a ruler? Yes. And is more than 50% of the graph paper used? Yes. All really important. Okay? Excellent. All right, get that question away now. So, part D. It was concluded that increasing substrate concentration reduces the effect of the competitive inhibitor. So it says explain, so remember, we're using data, so we're stating what we see from the data, but we're going to give a reason. Okay? So it says explain how the results of this investigation support this conclusion. Okay? So we already know, because we looked at the data before, we recognised that as the concentration of the substrate increased, there was an increase in the absorption rates. Okay, but remember, this is for 2 marks, so that's me just describing the data, i.e. the data from the table. Okay, so we have to give a reason for why that's happening. All right, so I'm going to have, so what I just said, so as the substrate concentration increases, there is an increase in adsorbents. Okay, so great, that's 1 mark. All right, and I know that what's happening is, if that, I think it was a pink colour, so when we can see that there's an increase from the absorptions, okay, so a kind of intensity in colour, then that's telling us that a product's being produced. Okay, so that is the reason behind that. So this indicates more product has been produced. Excellent. 1 mark, 2 marks in the bag. So this is my describe part, and this is the important part. In an explain question, you're giving your reasons for why that data, what's that data telling us? And then finally, I think that's this question, yep, finally, suggest how the results of this investigation would be different if a non-competitive inhibitor had been used. Okay, so we know that a non-competitive inhibitor basically alters the active site. Okay, so because it's altering, so your non-competitive inhibitor is binding onto any other area of that enzyme apart from the active site. So what happens is, as soon as it binds on to that other area, it alters the active site. So it kind of denatures it, which therefore means no substrate can basically bind onto it. Okay, so we know that's going to affect the substrate's ability to bind. Okay, so the absorbance levels will therefore not increase. The absorbance levels will remain low. Okay, so I'm going to say absorbance levels will remain low, or we could say it won't increase at each substrate concentration.